Before there was a sun, before there were planets, before there was Earth, our solar system had no form whatsoever. There was no light, no orbit, and no life. All there was a giant cloud of gas, floating alone in the darkness of the cosmos. This cloud is called a nebula, and it was from this nebula that our solar system's great journey began. In the first episode of this series, we'll travel back in time 4.6 billion years to a moment when everything was a void that slowly transformed into the system we inhabit today.
A nebula is a giant cloud of gas and cosmic dust. They are enormous, and a single nebula can stretch hundreds of light years across. If we could stand inside one, it would probably appear dark. Standing inside one, we wouldn't see the beautiful colors seen in telescope photographs, because those colors are only visible from a distance with a very long camera exposure. Nebulae are composed of hydrogen, the most abundant element in the universe, helium, a remnant of the universe's formation, cosmic dust particles, ice molecules, and heavy elements such as carbon, oxygen, silicon, and iron. These elements come from a single source, previous generations of stars that lived and died. When a massive star explodes in a supernova, it releases heavy elements into space. These elements eventually become part of the planets and the human body. In a sense, we are all stardust.
The nebula in which our solar system was born was likely the remnant of a giant supernova explosion. The supernova produced hot gas, pushed matter out into interstellar space, and filled the galaxy with clouds of dust and hydrogen. Over millions of years, this gas cooled and gathered into a vast nebula. The nebula was remarkably peaceful until one major event occurred. This vast nebula was initially stable. The gas was spread out, the pressure was low, and gravity wasn't strong enough to pull it together. However, a shock wave from another supernova passed nearby. This wave compressed parts of the nebula, making some areas denser than their surroundings. As the density increased, something crucial happened. Gravity began to take over. Gravity pulled the gas toward the center of mass, and once this process began, the nebula slowly collapsed inward. Imagine a giant cloud shrinking and forming dense clumps. These clumps were the precursors to all the structures in the solar system. When a nebula collapses, it doesn't just sit still, it starts spinning. This happens because of the conservation of angular momentum, a fundamental principle of physics that states that something that gets smaller spins faster. This phenomenon is similar to an ice skater. When she pulls her arms in, her body spins much faster. The same thing happens with a nebula. The smaller it gets, the faster it spins. As a result, the center becomes very dense. The outer edges become thin and wide. The nebula transforms into a giant rotating disk. This is the beginning of a protoplanetary disk, which will eventually give rise to the planets. And at the center of this disk, the pressure and temperature increase dramatically. As the nebula continued to condense, the densest part became the center. The pressure there was immense, and the temperature rose to millions of degrees. This was the beginning of the formation of a protostar, the precursor to the sun. This protostar did not yet shine like the sun does today. It was still just a ball of hot gas that continued to add mass to the surrounding disk. But at this stage, the center of the disk had become the most active and hot spot. The energy from the gravitational compression began to emit infrared light, and the greater the mass, the closer it was to the most crucial stage in the solar system's history. Over millions of years, the center of this protostar continues to gather gas and dust. The pressure continues to increase. The temperature continues to rise, until finally the protostar reaches a critical point. At this point, the star's core becomes hot and dense enough to initiate nuclear fusion, the process of combining hydrogen atoms into helium, releasing enormous amounts of energy. But that's for the next episode, the episode where the sun finally lights up for the first time.
In this episode, we see how the solar system began as a nebula collapsed due to a shockwave, how this giant cloud transformed into a rotating disk, and how a protostar, the precursor to the sun, began to form at its center. In the next episode, we'll explore the most crucial stage in the history of the solar system, the moment the sun was born and shone for the first time.